So now in this question he is asking, in 2D closed hexagonal packing, percentage packing fraction of the lattice is. Now in hexagonal closed packing we have to find out the percentage of packing, and the options given are, that is 68%, 74%, 78% and 90%. So we have to solve and find out. So let us move on to the solution. Now this is one atom and another atom, right? So how many atoms? 1 in the middle, and 1, 2, 3, 4, 5, 6, right? So let us join the center. Now this is hexagonal closed packing in 2D. So we have to find out the packing fraction of this, right? So packing fraction of this will be the total area of the circles divided by the area of the hexagon into 100, right? So first we have to find out the area of the hexagon. So we know that this is an equilateral triangle, right? So the area of hexagon. Now let us suppose this distance is A, and this A will be equal to 2r, right? From the center of this sphere to the center of this sphere, the distance will be 2r, and we are assuming it to be A. So that will be 6, because there will be 6 equilateral triangles, and multiplied by root 3 by 4 into A square. So 6 multiplied by the area of equilateral triangle. Now what is the value of A? That is 2r. So it will be equal to 6 multiplied by root 3 by 4 multiplied by 2r square, right? Now if we solve it, we will get 6 into root 3 by 4 multiplied by 4r square. Now this 4 and this 4 will get cancelled, and the value of area we will get 6 root 3 r square, right? Now we have to find out the area of the circles, right? Now this part is 1/3 of the area of the circle, right? So what we have to do, we have to multiply this part by 6, because we have 6 sections of like this, one here, here one, another one, another one, another one here, and one more here, because 6 atoms are touching this middle circle. So we have 6 sections like this, right? So we have to find out the area. So that will be equal to area of circle will be equal to 6 multiplied by pi r square by 3. So this is the area of the sections, and one atom we have in the middle. So plus pi r square. So when we will solve it, we will get, this will get cancelled out, we will get twice pi r square plus pi r square, it will be equal to 3 pi r square. And if we want to find out the efficiency, so efficiency percentage, that will be equal to area of the circles 3 pi r square divided by the area of the hexagon, and that is 6 root 3 r square multiplied by 100, and when we will solve it, we will get approximately 90%, right. So, our correct answer is the fourth one. So, answer is option number 4. Let us solve the next question. So, in this question is asking, following graph is not valid for lambda m is molar conductivity, lambda naught m is the molar conductivity at the infinite dilution, C is the concentration. A graph is given to us and that is between lambda m and root C. Same type of a graph is given in NCERT, and this line comes for Debye-Huckel-Onsager equation, which is for strong electrolyte only. So, 4 options are given to us. NaCl, that is strong electrolyte, K2SO4, that is strong electrolyte, benzoic acid, it is a weak electrolyte, CaCl2, that is strong electrolyte, means it is not valid for this, and our answer is option number 3, right. Let us solve the next question. So, in this question is asking, an aqueous solution of Na3PO4 freezes at minus 0.186 degrees Celsius, means the freezing point is given to us. Given that Kb of water is 0.512 Kelvin kg per mole and Kf of water is 1.86 Kelvin kg per mole, the elevation in the boiling point of this solution is. 4 options are given to us and we have to find out the answer. So, the solution will be, now we know that for elevation in boiling point, delta Tb is equal to I Kb into m, and delta Tf is equal to I Kf into m. Now, this is our first equation, this is the second equation. Let us assume this, right. Now, let us divide equation number 1 from the equation number 2. So, dividing one by 2, we will get delta Tb upon delta Tf is equal to, now this I will get cancelled, Ventov factor does not have any role to play here, molality and molality will get cancelled. So, we will have straight away Kb upon Kf. Now, value of delta Tb is given to us, and that is delta Tb divided by 0.186. So, if freezing point is minus 0.186, then delta Tf will be 0.186 and Kb is 0.512, which is also given here, 0.512, and the value of Kf is 1.86. So, this is 1.86. So, when we will solve it, we will get delta Tb is equal to 0.0512 Kelvin. Let us check in which option is there. So, this is the option number 2. So, the answer is option number 2, right. Let us solve the next question.